So in this video I just want to do a quick recap for you guys that are starting to study for externals. So we've kind of already covered this stuff, but I'm just going to go through some of the basics for us rather quickly, just to remind you if you've forgotten how to do these. So you can work through this worksheet without these or use them as a revision tool, the videos I mean. So let's take a look. The very first thing I guess you need to know for graphs is being able to find a rule given a pattern or a sequence of numbers. So it's our first step here is to find the rule. And remember, when we're finding a rule, we've got to calculate our first differences, potentially our second differences, and potentially a ratio to determine whether we have a linear equation or a linear rule, which means your first differences are constant, or whether we have a quadratic with our second differences being constant, and then the ratio of the first differences being constant will have an exponential. And the exponential, some of you guys may not have covered those yet, but that's okay. It is something you can work towards for the exams. And there's more videos to go into exponentials that you can use to help supplement your learning as well. So for all of these patterns, the first thing we've got to do is determine, before we can do anything with it, if it's going to be linear, quadratic, or an exponential. So my first step is always going to be to find the first differences. And again, that's 3 minus 0, if you wanted to think about what I'd be putting into my calculator. 3 minus 0, a difference of 3. And here I've got a difference between 3 and 10 of 7. That's 10 minus 3 gives me 7. And here I've got a difference between 10 and 21 of 11. So I notice my first difference is not constant. Those numbers are each different. So I'm going to investigate the second difference. That means I'm going to look here between the first differences. The difference between 7 and 3 is 4. And the difference between 7 and 11 is also 4. So here I have a constant second difference. So I know it's going to be a quadratic. And sometimes in the exam they actually ask you to kind of justify how you knew it was linear or quadratic, and you would say that exact statement. Constant second difference, so it's going to be a quadratic. Now, if we're going to go about finding the rule for quadratics, we'll end up using our calculator for these. So if you get out your calculator, we can take a look at it. If you remember, to find the rule, you're going to go into Stat, and you're going to enter in the pattern that we see. So we have 1, 2, 3, 4 down the left hand side, and we have a 0, 3, 10, and 21 down the right hand side. One thing to watch out for, you want to make sure that both of these lists that you've created here, the right and left hand side, have the same number. You don't have an extra row in one of them, like for instance an extra number there, uneven. They need to match up. Okay, now that you've got them entered, so we've done Stat. Next thing we're going to do is Graph. For F1, and then it's going to be Graph 1. And here you can stop, and this is a good place that I like to do a little dummy check here. Remember, quadratics are supposed to be slightly curved. So if I look at these 4 points here, they do look slightly curved, like it could make a parabola, so I'm probably on the right track that it's going to be a quadratic. I hit F1 again, so from Graph 1 we hit, that was Calc. And now from here, since I know that it's going to be a quadratic, because my second difference is constant, I'm going to hit x to the power of 2 here, that button, and I get my rule. So Calc x to the power of 2, because it's a quadratic, and you get your rule. And another dummy check to watch out for here, that r squared value, that should be equal to 1, so you want to double check it. If you get lots of decimals like 0.9999547, you've probably done something wrong. Go back and double check that you've put your points in correctly, and double check that it's a quadratic and not a linear or exponential by accident. So if I'm going to write out my rule, here I can see I'm going to be filling in basically the general rule they've given me. Y is equal to ax squared, but instead of a, I know that a is equal to 2. So I'll start with that. Y is equal to 2x squared plus bx, and in this case b is in negative 3. So I can say minus 3x. And c, here the plus c is a 1, so plus 1. And the last step that you want to do is you want to put this into context. And what we mean by that is instead of using x and y, you want to put in the letters that they've used. So remember in the tables, x is always first, and y is always second. So in our calculator, it's always going to be x and y, but in the table here you can see x in this case is actually p, and m is actually the y. So we are going to replace y with an m, 2, and instead of using an x, we'll use a p squared minus 3p plus 1. And that's our rule for the quadratic. So let's take a look at the second pattern they've given us. Again, same idea as before. I'm always going to check, because I don't know if it's linear, quadratic, or exponential, my first differences. First diff. Difference between 8 and 5 is 3. Between 8 and 11 is 3. And between 11 and 14 is 3. This one is constant. So I know if my first difference is constant, we have a linear equation because the first differences are constant. So if I'm going to find the rule for a linear equation, many of you guys know how to do that by hand. I'm not going to go over that one again, because if you know how to do that, you're probably in good shape, but I am going to go through how to do it on the calculator again. So again, to go backwards in the calculator, exit is your magic button. Hit exit. And we come back up here to the numbers we've put in. So I'm going to leave the 1, 2, 3, 4 because it's the same as before. And I'm going to replace the left-hand side there with 5, 8, 11, and 14. And again, just double check that your rows, you have the same number of rows in each column. So we're still going to use stat here. We would have done graph 1, calc, and here I'm going to use my little dummy check and take a look at those 4 points. They look awfully like they're in a straight line, so that's another reminder for me that it's a linear graph probably. So I'm alright probably to think that it's linear and to go ahead and follow through with that. So I'm going to hit calc, and then I'm going to hit x because it's linear this time. And on your calculators that you have at home, there's usually one more button you have to push that looks like this, ax plus b. My online version doesn't have that. But at the end you'll get to the same setup here. And like before, if you see an r-squared value, you want to check to see that that's 1. And since this one is 1, it's probably the right equation. So like we've done before, replacing the a with a 3. So y is equal to 3x plus b in this case is 2. And then I want to put this into context again, remembering that x is always first in the table and then y. So I'm going to write out m is equal to 3p plus 2, because m is my y variable in this situation, and p is going to be replacing the x in this situation. So I get my rule for the linear. I'm going to do the exponential video on its own, just because some of you guys aren't worrying about that just yet. So if you're interested in the exponentials, follow up with the other videos that are specifically for the exponential as well.